All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, it was pretty heavy on the note taking. Tonight, we actually got into some pretty interesting examples. So let's pick up where we left off. We were talking about image convolutions tonight, so I'm going to pick up there. So how then does an image convolution work? We'll start with the kernel matrix, and the kernel matrix looks something like this. This is our kernel matrix here. And the idea of this is that given a pixel, the middle pixel, for example, we're going to multiply each of the neighboring pixels by these values in order to get some sort of result by summing up all of the numbers together. So if we take this kernel, which we can think of as a filter that we are going to apply to the image, and let's say that we take this image here, so this is going to be our image. So this is going to be our filter here or our kernel. This is going to be our image. This is a 4x4 image. We'll think of it as just a black and white image, where each one is just a single pixel value, meaning each square is a single pixel value. So somewhere between 0 and 255, for example, those would be the values of the squares or each pixel. So we have a whole bunch of individual pixel values like this, and what we like to do is apply our kernel to our image. And the way we'll do that is look at the size of our kernel, which is a 3x3. So we'll take it and apply it to the first 3x3 section of our image. And what we'll do is we'll take each of the pixel values, multiply it by its corresponding value in a filter matrix, and add all of the results together. So for example, we'll say 10 times 0 plus 20 times -1 plus 30 times 0, and so on and so forth, doing all of this calculation. So let's go back up really quickly so we can look and see what we're talking about here. So imagine this is our filter here, and this is our image. So we would take this 3x3 and fit it over this image right here. So you can see our first box will be a 0, so that would be 0 times 0, like we said. Then it would be -1 times 20. Then it would be 0 times 30. And we would do that for every corresponding filter value to every corresponding image value. And when we add all of that up, we would get a 10. How will we get 10? Let's actually do the math really quickly and see. So if we had so let's say this is, so we can just negate all of these zeros right here. We know all of these outer ones will be 0 because anything times 0 will be 0. So let's go down really quickly. So this will be 0, this will be 0, this will be 0, this will be 0. Next, we know that all of these here are -1, -1, -1, -1. So we can just say it'll be -20 because if it's -1 times 20, it'll be -20. -1 times 10 is -10, -30, -30. Next, we would have a 5. So that'd be 5 times 20 will be 100. So we could do the math easily for this section here. We would have -20 plus -10 would be -30, plus -30 would be -60, plus -30 would be -90, plus 100 would give us 10. That's how we got the 10 for the first square. And then we actually have our box down here. So after we did all of that, we would have 10 for this box here. And after moving the kernel over 1, sliding it for the stride of 1, if you remember, our strides are always default 1 unless specified otherwise. So we would slide it over to this section here. This will be our new 3x3 grid to the right, and we would do the same process. And we would just repeat the process over and over until we get a value for each box in our 2x2. How do we know it's a 2x2? Well, if you remember earlier in a different module I explained to you, however many times we can move our kernel inside of our input image is how we determine our output. So if we had a 3x3, we can move it one more time. So this our starting location would be 1. We can move it one more time over. That would be 2. This would be our starting location at 1. We can move it one more time down. That would be 2. That's how we got the 2x2. And we would just do the math for every one of those positions moving forward until we came up with this solution here. So we have a 2x2 output with 10, 20, 40, and 50. So that's pretty much what we did for the night. It was a lot more note taking, and we did dive a little bit deeper, but I thought those were some interesting things that I could show you guys. And we're actually going to start compiling some code tomorrow. I didn't want to start that tonight to jam ourselves up. I want to make sure we had a grasp on everything we were doing. So yeah, of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.